Hi, my name is Hylton, and I will be discussing my keychain fixture design. In order to understand what we want out of our design, we must look at the goals for our manufacturing process. For starters, the fixture device needs to be easy to manufacture. This means that the part should take minimal time to fabricate and assemble, leading to a lower overall price. In addition to time, it's also important to consider the least number of parts required for a successful design. I calculated the forces required to keep the part in place during the machining process to determine how many fixturing clamps were needed. And lastly, we want a fixturing device to be easy to use. This means that it should be symmetrical, but different so that the part can't possibly fit in any other way than the correct way. So what should this fixturing base look like? This is the simplest design that came to mind. 2 locating rails, 2 Mighty Bite clamps, and 1 locating pin will attach to the rectangular fixturing base. The base has a locating rail at the top and 2 counterbore cutouts for locating and securing the fixture device. The only additional machining required on the part is the slots for the additional Mighty Bite fixturing parts. To fabricate the base of the tooling fixture, I created a sheet detailing the required machining for each step with its associated time. Overall, the part takes around 11 minutes to fabricate, which is shorter than the operation required to CNC the final keychain. After machining the base, the next step in the process is the assembly of the additional purchase parts. Taking a closer look into the required components, we have the fixturing base, the part to be machined, in other words, the final keychain component, the Mighty Bite clamps and nuts, as well as the locating rails and screws, and lastly, a 1/4-inch dowel pin. In order to accurately select clamping devices, we needed to know exactly how much force will be applied when using the 2 most forceful cutting tools. Those tools happen to be tools 22 and 23. The 2-inch 4-flute face mill and the 1/4-inch 3-flute end mill. Using the basic equation for the clamping force required, the overall clamping force only needed to be around 278 pounds, while the 2 Mighty Bite clamps were rated for 1,600 pounds. In other words, the selected clamping parts were more than enough to keep the part secure while machining. After analyzing the force equations by hand, I needed to certify that the force applied to the clamped part would not deform it using finite element analysis. Thankfully, the FEA showed that the deflection was less than 2 thou. They also showed that the stress applied from clamping is only 36 ksi, which isn't enough to deform the metal. In terms of cost, this part is rather expensive to manufacture. Some assumptions were made in the calculations, including the cost for engineering and estimation on time to engineer the fixture base. In total, this part came out to around $563. In conclusion, my design part took about 11 minutes to CNC. It is about $560 to manufacture and assemble. It withstands more than the cutting force that's applied, and there's more than a factor of safety of 2 involved. Thank you.